have this part that is a simple brass block, and well, then it has a 3/16 by 100 TPI thread feature on it. And a feature like this is usually like an adjuster screw or a fine adjustment, like a micrometer. I don't have a standard for a thread like this. I can't look up a standard for a thread like this as far as I've seen. And so what I do is I get a mating part. So this is the screw that the customer is going to use. Now we're over here on the optical CMM to take a look at this mating part, the 100 TPI fastener, and to try to get a quantified idea of what is going on. And you can see I already got it zoomed up here. We're looking at one side of the thread on the screen here. You can see that there's kind of a lot of dirt in it and things. We'll kind of zoom way up on it. And one of the things that struck me as, I don't know, maybe odd or not great about the way that this screw was machined is that it has these kind of what looked to me like maybe even unacceptably large fillets, where it appears to me that maybe the tool that they use to cut this thread is a little bit dull. And so, on this measurement, I'm showing a radius of 2.8 thousandths. We'll take another one. 2.8 thousandths. What you're looking at here is on the left side of the screen. Represents this male mating part with its 2.5 thousandths radius, and also this would represent the flat that I measured on it, and you can start to get an idea about what my portion is going to need to look like. One of the issues with thread milling, especially in a fine pitched thread, is that you get the real geometry of the thread interfering with what your concept of the thread may have been. So what you're seeing here is sort of a SolidWorks mock-up of some of the problems that you run into, and you may imagine two mating portions of a thread being exactly sharp, jigsaw that comes together, and there's no form error to it. But in reality, of course, that's not what you see. This not sharp tool and left around, and you can see that in this situation there's just no way for the two mating surfaces of the thread to ever come in contact with each other, because there would just be a collision there. And so when you bring it in just to view it, you can see that this mating isn't going to be possible because of the interference with the tip. With this 100 TPI thread, it's a 10 thou pitch, and it's approximately a 10 thou depth into the part as far as how far you're cutting in. And with a tap, you're going to be on it, turning that, and it's going to be at a funny angle, and you're going to be applying forces in a non-round way. And between the tap going in at a bad angle and you forcing on it and not being able to really feel what's going on, if you had to make more than one of these, and the thread fit needs to be pretty good, as seeing that it's used as an adjuster screw, I don't think you really want to do it that way. So I've chosen to do this by thread milling, and in this case it'll be a single point thread mill tool, and what that's like is a single tooth triangle shape that spins around, and you make one cut at one pitch of the thread. And what you do is you helically interpolate, or you do a helical interpolation toolpath to accomplish this thread milling. And what you're seeing here on the screen in SolidCAM is this set of helixes. And I'll show a solid simulation of it. So here it's roughing out the minor diameter, and then here's the thread mill roughing pass, and then there will be a thread mill finishing pass. And the way that I do this is I go back with my minor diameter tool to clean up any kind of burr or tips that might be in the thread, and then I run one more finishing pass with the thread milling tool and that really finishes it out nice. I'm out here on the Bridgeport mill to make a quick cross section in this brass part so that we can see what the thread engagement really looks like. So here's this cross section. What you're seeing on the right hand side is the brass piece that I've truncated what would have been sharp tips off of the minor diameter there, and they don't interfere even with this kind of 2.5 thou internal radius on the mating part here. The difference between being too tight and being just right was about 3/10,000ths of an inch on the diameter for the set point in the CNC mill. So these are the kind of things that you end up dealing with when you get into custom thread milling, and in particular a fine pitch like 100 TPI.